Okay, good evening. Tonight what we're going to be doing is we're going to be looking at the Activity 9 practice, specifically the Lesson 9-1 practice. So what our objective is for this video is that we can be able to look at a table of data, determine what kind of model would best fit that kind of table, and then use the calculator to create what's called a regression model, which is kind of an estimate for a best fit line. So when we're looking at this, it's question 1, examine the data in the table. What type of function could be used to best model the data? And so we're going to explain our reasoning. Option 2, we're going to use the regression capability of our graphing calculator to find a model that would best represent the data in item 1. Okay, question 3, graph the equation you found in item 2, list the important features of your graph, approximate any values to 3 decimal places. Now, question 3 is more along the lines of the calculator work that we did in class. That's going to be things like your y-intercept, your x-intercepts, okay, if it has any, your end behavior, and so on and so forth, okay. Any locations of turning points, the inflection point, where is the function increasing, decreasing, those kind of things. Now when it says approximate any values to 3 decimal places, that's going to be fairly standard practice. The more decimal places you use, the more accurate your graph will be. So what do? The first thing that we need to do to determine the type is we're going to plot our points on a graph. You're going to determine the degree based on the number of your turning points. So this is a scatter plot of the table from question number 1 on the previous slide. So when I connect the dots, I can kind of tell that my graph is kind of shaped like a quadratic, kind of shaped like a parabola. Now, the equation is not going to be a perfect fit because it's not a perfect parabola, but it will give us a fairly good estimate of what this parabola's equation should be. So to create a model function, and this is a function that's going to make an estimate, it's going to be fairly close, we're going to start by pressing the stat key. The stat key can be found on the second row, right next to the directional pad and underneath the delete key and next to the variable key. Once you press stat, it's going to take you to a series of menus. We have 3 menus here. We have edit, calculate, and tests. For this class, we're never going to use the test submenu. We're going to focus on edit and calculate. Now under edit we have a couple of options. Okay, option 1, this is the one that we're going to use the most. Option 1, edit, allows us to type in our table just exactly as we see. Option 2 and 3 we're going to kind of ignore. Option 2 is going to sort ascending, and option 3 is going to sort descending. So the bad thing about the sort ascending and sort descending is if we have ordered pairs, the sort ascending is going to put both the x's and y's in order from smallest to largest. Problem with this is it will do the x's and then it will do the y's, and so we never want to use the sort ascendings or descending because it's going to completely rearrange the order, and it's not going to pay any respect to what should be paired with what. Option 4, clear the list, so that's going to basically just delete your tables. And option 5, set up the editor. You're never going to want to set up the editor. Instead of setting up the editor, that's where you're going to want to just reset your calculator with the second plus 712. That's going to be an easier way. So what we're going to do is press enter under edit and type in your table. After you've typed in your table, we're going to press stat a second time. And this time we're going to use the right arrow key to select calculate. Now on this screen, under calculate, there's several different things. There's 1 variable stats, 2 variable stats, and several things, but we're mostly interested in these bottom 4. So these bottom 4, we have linear, y equals x, We have our quadratic regression, y equals x squared if that's the equation we want to make. We have cubic regression if we want to make a cubed function. And we have the quartic regression if we want to make y equals x to the fourth. Now, on our equation, we wanted to make y equals x squared, so I'm going to choose option 5, the quadratic regression. Okay, and again, that's because the scatter plot looked like a parabola. Now, on the screen, when I click the quadratic regression, I'm going to press enter, and it's going to give me an answer that looks fairly like this. So, y equals ax squared plus bx plus c. A equals negative 0.88636, B equals negative 3.6287, C equals 4.6636. Now the instructions were to go with respect to the third decimal place. So when we set up our actual model for the regression, we'd have y equals negative 886 x squared minus 3.629 x plus 4.664. So you actually do need to plug these values in for A, B, and C. And when we're going to the third decimal place, we can see, well, on the negative 0.886, the 3 is not going to cause it to round up. But on B, negative 3.6287, the 7 will cause the 8 to round up to a 9. And so we always want to make it as accurate as possible. So make sure you're rounding correctly. But overall, that's how you make a regression feature. Okay, so if I'm looking at question 4, I've got this smaller table right here of x and y values. And again, we want to make sure we type those in the calculator exactly as they show up. So the first thing I'm going to do is I'm going to plot those points on a graph. And when I look at this kind of scatter plot, when I go to actually connect my dots this time, I can kind of see that I have two turning points. I've got a maximum and a minimum. Since this graph has two extrema, a relative max and a relative minimum, that's going to tell me I probably want to go with a degree 3 polynomial. So I'm going to go with a cubic regression this time. I'm going to, so on this, nice. So again, I'm going to choose a cubic regression. Now when I choose a cubic regression, I'm going to push enter the same way I did last time. And this time it's going to give me the following information. Y equals ax cubed plus bx squared plus cx plus d. And it's going to give me a list. A equals 0.475. B equals negative 2.848. C is 2.7598, which I'm going to round to 2.760. D would be 3.062. And so when I fill in my actual equation, I would say it's 0.475 x cubed minus 2.848 x squared plus 2.75 or 760 x plus 3.062. And that would be my cubic regression. That would be my best fit of making a cubic model fit for that equation. Now typically what's going to happen is higher degrees tend to be a little bit more accurate because you can do a little bit more things with them. But, I mean, like we've been seeing in class, the higher the degree, the harder that they can be to work with. So we typically want to go with a minimalistic approach with what degree we pick. We could have picked a quartic function for this graph, and it would have come out fine. So when I back up, I mean, it would have just simply maybe had it go up. Or maybe it would have had this side go down. Either way, it could be a good fit, it might not. But that's kind of the the gamble that we take when we make an estimate for one of these regression features. If you have any questions, please let me know.